And here we have a few more examples involving derivatives of trigonometric functions. Let's take a look at example number 8, where we have f of x equals tangent x times cotangent x, and we're asked to find the derivative of that function. Now, for things like that, yes, we can use the product rule without a doubt and then try to simplify our answers. But sometimes, because trigonometric functions, they simplify nicely, if you can think of like a way to simplify it before you even begin, that may save you a lot of time later on. For instance, tangent times cotangent. Is there a way we could rewrite that function to try to simplify it? You know, I could write both tangent and cotangent in terms of sines and cosines. That would be one possibility. And the other possibility is, okay, do we remember what cotangent x is in terms of tangent x? If you said 1 over tangent, you are correct. So far I'm not taking the derivative. I'm just using properties from trigonometry to simplify the given expression. Tangent times cotangent is the same as tangent times 1 over tangent, which is 1. So f of x is the same as 1. So then what will be f prime of x, the derivative? What could be simpler, right? It's just a constant. The derivative is going to be 0. That's all we have to do for that one, if we notice that property. If we didn't, we would have to use the product rule, and then we'd have to do a lot of simplification to get to the same final answer of 0. Okay, what about something like tangent x divided by 1 plus tangent x? So for that one, we need to again use the quotient rule of differentiation, right? So again, there's no simple way to simplify tangent over 1 plus tangent, so there I'm going to use the quotient rule. So with the quotient rule, the bottom becomes the given denominator to the second power, right? For the numerator, we have the lower quantity, which is 1 plus tangent x, times the derivative of the higher one. Now, what was the derivative of tangent? If you said secant square of x, fantastic, you are correct. Remember, there's a minus sign in the numerator for the quotient rule. So far, we've done lower d high. Lower times derivative of higher. Now let's do minus high d low. The higher times derivative of the lower, which is tangent x, times the derivative of 1 plus tangent is, first of all, derivative of 1 is 0, derivative of tangent is secant squared. And now all we need to do is simplify all of this. Let's begin by distributing the secant square over the 1 plus tangent x. So we've got secant square x plus secant square x times tangent x minus, and those two are already as simplified as you can get, secant square x times tangent x. All over the same denominator, which was 1 plus tangent x quantity to the second power. And do you see a simplification now in the numerator? Do you see the plus and minus are the same term, right? Secant square tangent plus and minus, so those cancel. So our final answer will be secant square x all over quantity 1 plus tangent x to the second power. And I'm going to take a moment now to go back to one that I had skipped earlier, number 7, where I had cosine x times 1 plus cosecant x. In that situation, like we did in number 8, you still have your options. You could apply the product rule, or you could say, I wonder if I can simplify this before even I begin. You could do a little exploration, and it turns out that's a lot easier. So with the products of trig functions, if you see a simplification right away, try to do that before you proceed with differentiation. Like, what do we know about cosecant x? So first I'm going to rewrite cosine x times, instead of 1 plus cosecant x, I'm going to write 1 plus, okay, does everybody remember cosecant is 1 over sine x? And now let's distribute this to see what we get. Okay, so cosine times 1 is cosine x plus cosine times 1 over sine is cosine x over sine x. And what do you know about cosine x over sine x? Is it tangent or cotangent? Cotangent, right? So here we have then cosine x plus cotangent of x. Okay, now I'm going to take the derivative. Now I'm going to find y prime. Okay, derivative of cosine is negative sine x. And derivative of cotangent is, that was one of the, if you know derivative of tangent is secant squared, cotangent becomes negative cofunction, negative cosecant squared. And if you think that was a lot of work, I would say go and try the other approach. You would see it's a lot more work. That's when you use the product rule from the beginning, because then you have to know the derivative of cosecant function, and then it gets messy. So this is going to be an easier way to do that question. And here are just a few more examples about finding derivatives involving trig functions. Take a look at number 11. F of x equals the square root of x times cosine x, then what would be f prime of x? So here we have to use the product rule. There's no way of getting out of that. So let's try. So f prime of x equals, I keep root x as it is, times derivative of cosine, which is negative sine x. With the we're using the product rule. Remember, in the middle there's a plus sign, plus, write the second quantity times derivative of the first. Second quantity is cosine of x times derivative of the first. I hope by now we're familiar with the derivative of square root of x. You can do it the long way, but you should get 1 over 2 root x. So technically we're done, but we could get common denominators. You might see sometimes answers left in a different format. So I'm going to multiply here top and bottom by let me see. I think I'm going to, this one actually will stay the same. Let me multiply the first one top and bottom by 2 times the square root of x. So that way both of them will have the same denominator. So if I do that, 2 root x times root x, I'll have 2x times negative sine x, put the negative up front. So negative 2x sine x plus cosine x. Because they have both the same denominator, I'll write in one common denominator of 2 root x. So I could leave it like that. If necessary, I could even do one more thing. I could multiply both the top and the bottom by the square root of x to rationalize denominators. I'm not usually very picky about that, so you can leave it like this, or if you prefer, you can also do the other one. That's fine. So 2 less examples, number 13 and number 14. Okay, number 13. We have f of x equals sine x over tangent x, and we will take the derivative of that quantity. Again, you might say, okay, this seems like a quotient rule example. It turns out if you try to use the quotient rule, it's extremely tedious. So my hint to you is, can you try to do that problem first by simplifying the ratio, simplifying the sine x over tangent x. How could we do that? Well, tangent x is sine over cosine. Let's write it that way. That's a common trick we've learned in trigonometry. If you're stuck, write everything in terms of sines and cosines, right? So I'm going to do that. So tangent is sine over cosine. But because it's in the denominator, I'm going to flip it and multiply with the top. So now you have sine x times cosine x over sine x. And as you can see now, the sine x can be canceled. So all we have is cosine x. So is that our final answer? What is that equal to? This is still the same, f of x. We're just simplifying it, right? So f of x is cosine x. That is not our final answer. To finish the question, we need to know what is f prime of x. But now that should be really easy, right? What is the derivative of cosine? Negative sine x. So that is an easy way to finish it. I think it's an excellent exercise. In case you're curious, do that one also with the quotient rule. And you're going to have to do like massive trigonometric simplification to see that even with that approach, you're going to end up with negative sin x. But I think it's an excellent exercise. If you have the time, I would highly recommend that. Okay, let's take a look at the last example. And if you want to get it started and then come back, check your answer, that might be a good way to go about it. And here's one last example about finding the derivative of a trigonometric function. In this case, we have h of x equals tangent x minus 1 all over secant of x. And we're going to find the derivative of this function using the quotient rule. In this situation, you could still try to simplify this first, and it might actually be a little bit easier. But just for the practice, I'm going to use the quotient rule here. And the way you would simplify this, you can write it as tangent over secant minus 1 over secant. And then simplify each of those and then take the derivative. Okay, so that might be one possible way to do it. And then the other possible way is, okay, we're going to use the quotient rule. So our denominator is going to become secant square of x. For the numerator, we have the lower one, secant, times derivative higher, which is secant square, and minus the higher one, written exactly as it is, tangent x minus 1, times the derivative of the lower, and we know the derivative of secant is secant tangent, so secant x times tangent x. And now I have a lot of distributing to do. The secant times tangent will be multiplied by each of these two terms on the top. So here I have so far secant to the third of x minus secant x tangent x times negative tangent x. That's minus secant times tangent square x. And then the minus with the minus, it will give me the last term will be a positive secant x tangent x. And everything is divided by secant square. Simplify it. I'm going to take a secant x from all three terms on the top. Okay, so let me do that. So secant x times, so then I have secant square minus tangent square plus tangent x divided by secant square of x. Now, at this point, I just say simplification because secant square minus tangent square, there is an identity for that. Do you remember the one identity I mentioned to you a while back, which is 1 plus tangent square equals to secant square? Okay, what I have though is secant square minus tangent square, so you subtract tangent square from both sides. What do you get? We get 1, right? So this can be simplified as just 1. So you're going to have 1 plus tangent x in the middle there. So 1 plus tangent x. And don't forget up front you have a secant x, and you're dividing everything by secant square of x. And now when we simplify it, secant over secant square, you only have a secant left in the denominator. So 1 plus tangent x remains on the top. So finally the answer will be 1 plus tangent x divided by secant of x. Phew, that was a long one. But again, some of these, you try something, it doesn't work, you go back, you try something else. That's how math is. It's not always a very smooth, linear path forward. Sometimes there's zigzags. You go up, you go down, you go up. Hopefully at the end, you're going to solve the problem.